thank you everyone for showing up for my keynote here. So a bit of trivia, the last time I spoke at CMC was 1984. I was a lot younger then. I wanted to start out by asking a question. So who here is not a Netflix subscriber? Uh-oh. All right. Well, I will see if I can change your opinion of our service in the next hour or so. So I'll start here with this picture. This is the NASA Pleiades supercomputer. It lives up the road from us at the NASA Ames Research Center in Moffett Ames in Mountain View, California. It's about 161 racks of computing equipment, almost 12,000 nodes, almost 250,000 cores, and one of the largest supercomputers in the world. Now, think about how many IBM Z-series systems that would be, right, to build something this size. NASA uses it in order to find planets around stars in the galaxy. And in fact, someday we might go to one of those planets and visit. Now, why is this interesting to me at Netflix? Well, because every 48 hours, we basically build and destroy enough capacity to build one of these machines in our data centers. So what I want to do is to spend the next hour or so talking you through how we go and think about the problems of managing capacity like that, the performance problems that we run into with trying to manage that capacity, and give you some insight into how we look at the world and the things that we do in the company to make this possible. My talk is basically 3 pieces, plus the special piece at the end. I want to talk about strategy, operations, and tactics. So the way I like to think about this is we're running this race. So if you're going to run a race, the first thing you do is you look at the track. You think, okay, what's the strategy for this particular track? Where are the passing zones? When are we going to pit? When are we going to change tires? Next, operations. So think of that as the people in the pit or in the garage. What they're trying to do is to make the car go as fast as possible. They'll be tuning things. They'll be working on things. And lastly, tactics, which is so what does the driver do on the track at any particular moment in order to go as fast as possible? Now, before I dive into that, I wanted to give you all a little bit of history of Netflix and a little overview of how the service works from your perspective. So we started 20 years ago, 1997. That's our founder, Reed. We were a DVD business, so essentially all you can eat DVDs for one low monthly price. You can think of that as a very early version of binge watching, except with a very long latency because the post office was involved. So let's jump forward now 20 years. We're now streaming. We stream in 190 countries around the world. We stream in multiple different formats, HDR, 4.1. We have multiple different sound formats. We just recently introduced Dolby Atmos sound. We're building our own studio down in LA. There's about 1,000 people down there now. We're going to spend about $6 billion on content this year, $8 billion next year, and that number is just going to continue to grow. Our big push at this point is into Netflix originals, right? What we've decided is that's where our future is going to lie, is basically producing content for all of you to watch. We run on over 1,000 different devices. So everything from smartphones to to PlayStations, smart TVs, computers. Pretty much everything that has ever run Netflix will continue to run Netflix. That's the commitment that we're making to our customers. In terms of subscribers, 10 years ago we started out streaming, just in the United States, Latin America, Canada. Had about 6 million subscribers that first year. We just recently through actually 5 parties around the world because we crossed 100 million subscribers. The numbers are out. It's actually above 100 million now, and we're on our way to 200 million at some point in the future is the hope there. But you can see the service is really growing very fast, and with that growth brings a bunch of challenges around managing capacity, managing performance. All right, so for those of you who are subscribers, let's say that you're at home one weekend, actually particularly after this conference, after everything I've said, and you go, okay, I want to sit down with my family to watch something, or better yet, you're going to binge watch something like the new season of Stranger Things. So let's take a look at what happens first from your perspective and then from our perspective back at Netflix. Most of you will encounter this first picture here, which is what we call the profile gate. Even though we have over 100 million subscribers, each of those subscribers may have multiple profiles. The thing that I'd like to point out about this is my profile here. I was in the middle of watching Luke Cage back then. But it's suggesting movies or content I'm in the middle of for me to watch. It does keep track of what you've been up to. But in particular, the thing that we wind up doing is for each and every one of you out there, we compute a new profile every night. So we use our capacity to figure out, here are things that you, based on what you watched, based on things we think you might want to watch, based on things that people around you will watch, we will recommend things to you. And each of that we compute for everybody. We're in the process of trying to move that to more often than once a night, so that we, for instance, people watch different things in the morning that they do in the evening. So we might suggest different things in the morning that we would after school, for instance. Once you've selected your profile, you wind up here. This is called the list of movies, or LOLAMO for short. Each of the boxes here, the box art, you'll probably spend about 1 second looking at one of those things before you wind up choosing something. In general, you'll look at about 6 rows before you'll pick something. So from a performance perspective, what we'll do is we'll load those first 6 rows very quickly. Then in the background, we'll continue to load up to 20 more rows of things. The rows actually will change ordering. We do something called adaptive row ordering. So based on if you watched something very recently, we'll show you something that you were in the middle of watching. If you haven't watched something, we'll show you something we think you might want to watch. And so again, we'll sort of keep track of what your actions are and then present you with something that we think is what you want. Our goal is to get you to watch something that you really are going to fall in love with as quickly as possible. And in fact, that's a lot of what my goal is as a performance manager there too. All right. Once you pick something to watch, you actually get to the thing that you really care about, which is this play button here. All right, so this movie details page, you can look up new episodes, you can look up who the stars are, a particular thing, but really what we're interested in having you do is to actually press that play button, because that means that you're now engaged in watching something and you're having a good time. All right, so that's the view from what our customers see. So what do we see from our end? Whenever you press that play button, there's a lot of stuff that goes on in the background. So it wouldn't be a talk about performance without charts. I think this may be the only chart I have here. Up at the top there says global SPS. So SPS is short for stream starts per second. One of the things that we track very closely is the number of times people press that play button, and we record that as an event that we call a stream start. Now stream starts are amazingly reliable. They basically go up in the evening as people start to watch more. They go down at night as people start to watch less. What we see here is a chart that shows you stream starts over the course of about a week, about 4 or 5 months ago. Now, stream starts are so reliable that the colored region of the chart is actually this week's data. The black line is 2 weeks ago. And if you look closely, there's a little gray line, which is actually last week. So from week to week, day to day, right, the way people watch our content tends to be really repeatable. In fact, it's so repeatable that we can use it in order to find problems with the service. So for instance, if an Xbox 360, the stream starts suddenly fall off the cliff, then alarm bells will go off. We'll start looking into it to see, okay, is there something wrong with that part of the service that needs to be fixed? So that leads to our first quiz. So there'll be several quizzes. So who can tell me what happened August 21st of this year? What? Did someone say the eclipse? Yes. So we were wondering why 10% of the people out there decided to watch the eclipse and not watch Netflix. So those of you who did that. But the thing I wanted to point out here is this is stream starts in the US during the time of the eclipse. So the first blue arrow there, number 1, is the West Coast. You can see that what happened is people stopped streaming leading into the eclipse, right? The next blue arrow is the Midwest, and the third blue arrow there is the East Coast. As soon as the eclipse was over, notice how the line goes right back to its trend. So there are things that we can see from this. For instance, when soccer games start in South America, football, we can see all kinds of events that happen because stream starts will change as people change their viewing habits. Now, The infrastructure we use, everyone knows, is Amazon Web Services, so we run it entirely in the cloud. We actually started out in our own data center before I joined back in the sort of 2007 timeframe, but we very quickly moved into Amazon Web Services. We run in 3 regions around the world, the East Coast, the West Coast, and Ireland, and that essentially serves all 190 countries around the world. So no matter where you are, you wind up going to one of those data centers in order to start your sort of Netflix adventure. Across these 3 data centers, we run over 100,000 virtual machines. And that number actually scales up and down in response to the number of stream starts. So as more people start watching, we will scale up more virtual machines. As they stop, we will start to scale those down. So generally, we talk about it as about 100,000. It's actually between 100 and sort of 160,000 machines. It really changes that much over time. And so if you go back to where I started, with the capacity that we sort of build and destroy, that's where a lot of that comes from. Now, when you go to Netflix.com, you actually just see the one sort of entry portal here. Behind that is actually those 3 Amazon regions. Each of the regions are basically redundant, so they have the same data. You could travel around the world. Your account will work no matter where you are. The group that actually sits next to me is responsible for traffic. And what they'll do is as devices come in, software will say, OK, you're coming from this region, you're this device. It will then send you off to a region that's appropriate for you. Now, because the regions are redundant, we can do something that's actually fairly clever here, which is that if we have a problem in a region, we can actually divert all the traffic from that region to the other 2 regions and still keep going. An interesting factoid here is when I started Netflix, we did an exercise. Actually, we've been doing it for a while. It's called a chaos Kong exercise, and I can go into the details of that a little bit later. But you would get this message that said, OK, we're doing a Kong exercise. It's Thursday at noon. The traffic people would pull the big switch, and traffic would leave one of those 2 regions and go to the other 2 regions. We would basically shut down the virtual machines that are running in that region. We'd stay in that state for 24 hours. At the end of 24 hours, you throw the big switch back the other way, right? You divert all the traffic that was in those regions back. You get back to this picture here. So a couple of things to note about that. The first is, you all have never read about this in the newspaper. So we basically do it once a month to make sure it works. Right? It doesn't really impact our services at all. The other thing that has changed is when I started, we did it once a month, and we would send out mail to all of engineering saying, we're about to do a Kong exercise, so be prepared. Well, so now we do them every other week, and we don't send mail anymore. So essentially, we just surprise engineering by shutting down the service in one of the regions. And they need to be able to respond to that. Actually, all of our services need to be able to respond to that kind of failure. The other thing is, when I started, it took about an hour and a half for us to evacuate the region. We have done significant improvements here, and now we can do it in less than 10 minutes. Okay, so that's moving essentially the content. Actually, it's really starting thousands of VMs in the other 2 regions, right, in a very short period of time, and shifting traffic at the same time, and doing it without anyone actually noticing that you're doing this. And afterwards, you can ask me how we made that work. It's actually fairly clever. Actually, I already spoiled my surprise here. So inside these data centers, we have hundreds of microservices. And actually, this picture is a map of all the services that we run. So each microservice is basically a collection of virtual machines. So anywhere from 3 to over 1,000 virtual machines running together in order to produce one of those services. They all work in conjunction to get you what you want. You enter over there and sort of wander around through the back of it. Now, the reality is, any particular request doesn't use all of the services. The total service is divided by device type. So for instance, smart TVs will use one set of services, mobile devices will use another set of microservices. But all of them are working in concert in order to give you that streaming experience. And by streaming experience, I mean everything that happens between Netflix.com to when you press play. We actually have our own content delivery network that actually streams the content to you. On this slide, I wanted to point out one sort of fascinating thing. So the white dot there is called API prod. Think of it as a big sort of central switching network. pretty much every request that comes to us from all the 100 million subscribers will go through the API prod cluster. It's close to 1,000 machines. Now, inside that cluster, the service has what we call endpoints. So there'll be an endpoint for iPhones, there'll be an endpoint for Android devices, an endpoint for PlayStations, et cetera. So we'll have hundreds of endpoints for different devices. During the course of a day, those endpoints will be replaced by the teams that maintain them several times a day, potentially, to fix bugs, to introduce new features, et cetera. The API prod cluster will get replaced 3 or 4 times a week, also rolling out new features, rolling out bug fixes, et cetera. Again, we managed to do all of this without really interrupting the service at all. Okay, another story. December 24th, 2012. I'm not going to ask you what's special about that date, other than it's Christmas Eve. So at Netflix, we were streaming basically South America, Canada, the US. The operation was still small. It was Christmas Eve. Engineering, everyone was thinking about, okay, going home, dinner with family. Next day is Christmas, time to relax. It's been a good year. Around 12:30, alarms started going off. People couldn't stream things. What was happening? We determined pretty quickly that load balancers inside Amazon were starting to fail. Around 3:30, the next wave hit. More load balancers starting to fail. What could possibly have gone wrong? Well, it turns out Amazon, one of their technicians had pushed a maintenance update, because as we all know, Christmas Eve is when you push all your big maintenance updates. And unfortunately, the side effect of this maintenance update was to cause load balancers to fail. It took until 8:30 the next morning to get this problem resolved, because unfortunately, the remediation at their end was to reload from backups, right? So why is this date important in Netflix history? This was the event that convinced us that we had to move out of a single Amazon region and into multiple Amazon regions. Prior to that, we were in one region, we were in multiple availability zones. That seemed to be sufficient. We had done a bunch of stuff to increase our reliability. That seemed to be working. But it was this event that went, oh, wait a second, your whole data center could just go away. And then what are you going to do? So now we get to strategy. So what are you going to do if your data center is going to go away? So you look at this road here, and you start to think, okay, how am I going to navigate that? Well, the first thing is you need to identify all the key attributes that you really care about. So for us, streaming, that's the key thing. Hundreds of virtual machines all working to give people streaming ability, right? We need to make sure that those are running 24/7. Behind that streaming platform is a set of platform infrastructures. For instance, we have a monitoring framework. Runs 15,000 virtual machines that monitors everything we do. Right? So every time you interact with some device or interact with a service, we record some event. We also have a set of infrastructure that supports the streaming part of the business. So for instance, all the little pictures that you saw, the box art, that comes from a thing that we call the video metadata service. It's got over 400,000 little videos, right? We recently started doing pre-rolls of trailers and things, right? So all those videos are contained in this service. It's another big cluster of machines. It needs to be able to serve 1.3 trillion requests a minute, right? So we need to be able to scale up to serve that kind of traffic. Big data. We have hundreds of petabytes worth of data that we maintain. Of course, again, every time someone starts a movie, anytime anything happens inside the data center, we track all of that stuff. We transmit about 800 terabytes worth of data, or data pipelines. And so our persistence tier, our data tier is actually very large. And lastly, encoding. So all of those devices that you can stream on all take different encodings. We wind up encoding all of the content you see ourselves, and then distributing it out to our content delivery network for people to go stream. We actually use our spare capacity in order to do all the encoding kind of in the time when people are asleep. So while you all are asleep, we're busy encoding the next day's set of things. The other part of our strategy here is making sure that you have the right tools available in order to go solve all the problems that you want to solve. So we're very much a tool-driven culture. We write a lot of our own tools. We use a ton of open source. In fact, almost everything that we use is open source. We've actually published a set of tools as open source. So a lot of the things, in fact, some of the things that I will show you are available for all of you to use if you want. Our biggest tool, though, is the Amazon Web Services and the cloud. And within there, we have a lot of different choices of things that we can do. There are 4 main instance classes. I'm assuming everyone is at least familiar with Amazon Web Services, has probably looked at their website, looked at what they have. There are multiple different instance types that you can pick. For the most part, we stick to these 4 main ones here. We have a general purpose set, which is available for pretty much everyone to use. We have memory optimized, so we have in-memory databases that we maintain, and so we'll use the memory optimized instances for those. We have storage optimized instances that we'll use for our persistence tier, and then network optimized, because our persistence tier and our caches, because we cache a ton of stuff, all need very low latency. So I have a person who works for me who basically spends full time sort of benchmarking Amazon instances so that we can tell our customers internally, here's the type of instance you should go run on. In addition to the instance types, they come in multiple sizes, so large to extra large to actually very, very extra large. And one of the things that we'll recommend to people as a performance group is, here's the instance that you should run on for your needs. But these, you can start to see now that there's this matrix of choices that we get to make with all of these services. And to a certain extent, every service gets to make their own choice about what they want to run on. And then lastly, storage. So Amazon has both SSD and non-SSD storage types. They have memory, storage memory attached to the instances directly. They have memory in the cloud. We spend a bunch of time looking at all of those things and trying to decide what's the best for each different service that we want to use. Now, within our capacity planning function and our engineering functions, we have a set of knobs that we can turn in terms of how we control the capacity that we give to people and the performance that they get out of that capacity. At some level, the first and most important knob we turn is pricing. So each Amazon instance has a different price that you get to pay for it. We spend time looking at the utilization of the different instances and making sure that you're running on an instance that actually meets a good price point for you. Because we're a really large Amazon customer, we get to negotiate pricing with them. And we have a really good understanding of how they're thinking about pricing and where they're going. That helps us to plan a lot. So the capacity planning function, which actually is only sort of 3 people, does spend a lot of time really going over spreadsheets and trying to understand the different sort of pricing choices that we have there. Instance availability. So being in the cloud, not all instance types are available in every region in the numbers that you need them. We need to track that, and we need to make sure that if you're going to ask for 1,000 of an M4 X8 large or something, that those things are actually there. We work very closely with the capacity planning people to make sure that the right instance types are in the right place at the right time. Applicability. So you go back to the list of choices I started out with. Do you need a high memory instance type? So people in my organization will work with the different service providers in order to say, okay, so your application needs to do these things. So you probably need this kind of memory, or you need this amount of memory. You need this kind of CPU. We'll run benchmarks with them. We'll look very closely and work closely with them on their applications in order to go figure stuff like that out. And lastly, reservations. We use reserved instances inside Amazon, which basically means we prepay for capacity, and we'll buy a ton of it. But that means that we have guarantees that we can depend on for certain functions. And we take very good advantage of that, particularly with encoding. Since we have all this reserved capacity, we can now use it for other things. So capacity planning is really important. This is a picture of an accident from about 10 years ago. You need to understand what your capacity is. You need to understand how you're going to use it. So some of the things that we really focus on is really understanding what our capacity in the cloud is going to be, and then how we're going to distribute our load in various ways to use that capacity as efficiently as possible. The gentleman on your left there is what I could claim is one of our capacity planning engineers. So actually, if any of you are working in cloud environments, then this may feel very familiar to you. The thing about the cloud is it's infinite, right? Everyone tells you that. Just go get the capacity you want. Well, the reality is it's not really infinite. And the other reality is you may walk off a cliff here thinking, OK, I'll go grab some resources. Oops, they're not there. So now I need to be prepared to respond to that. And we actually do see that happen, where a cluster will try to grow, they'll try to request instances, and they'll get what we call iced, which is that Amazon will come back and say, sorry, that capacity is not available. You need to go do something else. And we built a system we feel is really resilient to that type of behavior. So on the negative side, you might say, it's hard to know that you have all the capacity you need. But on the positive side, the capacity, if it is there, it's there for you to use. It's easy to get. Amazon is doing us a big favor. They're managing all the hardware for us. As new instance types come along, they'll go test them, they'll go deploy them. That takes a lot of pressure off of us. We'll actually spend a bunch of time benchmarking them and making sure that they're right for our needs. We'll work very closely with them on that. But once they go into production, then we know when they're going to ramp up, we know when they're going to be available, we can start to use them when we need them. The list here is the sort of 5 things that the capacity planning people really focus on here. Thing number 1 is forecasting. So you saw the SPS chart back there. That chart, even though it looks like it's kind of constant from week to week, it's actually trending up. As we add more customers, that number just goes bigger and bigger and bigger. So our capacity planning people need to spend time working with the people in financial planning to try to forecast how many subscribers will we have 6 months down the road, so we can go forecast cloud capacity for that. We spend a fair amount of time on fleet analysis, so understanding what our utilization is of all the different VMs, and working with each of the individual teams to say, OK, so you're growing at a very fast rate. Why has your cost doubled in the last 2 weeks? Is there something we can do in order to help you reduce that cost? And actually, that's where my engineers will now come into play to help with tuning, et cetera. Trough management. I mentioned the trough briefly earlier. So we essentially run this internal spot market, which is, OK, I have this application. It's essentially a batch application. I need capacity for it. Is that capacity there? Can I use it? And the thing with the trough is you need to be prepared to be kicked out of it because some other higher priority thing may come along. Turns out encoding is an operation like that. Predicting what you all might watch is an operation like that. We can kick you off the machine and give it to somebody else with no problem. And again, you need to design with that in mind, that you may just stop suddenly and then have to restart later. Holiday purchase. So what do you think is one of the favorite gifts for people at Christmas? Netflix. And what do people do when they get Netflix as a gift? They start watching almost immediately. So we see actually a big spike up in the week between Christmas and New Year's. And so around this time right now, actually, our capacity people are ordering more capacity in anticipation of what we think that spike is going to be. As it turns out, I think that's the only holiday that we actually do buy extra capacity around, but we do keep track of these things, right? So if we see some event that may encourage us to get more capacity, then we will go do that. And last but not least, there is an on-demand pool at Amazon that we can take advantage of in a pinch. Now, we try to buy as many reserved instances as we need so that we can use those because they're cheaper. But at the end of the day, there is reserved capacity. It is a little bit more expensive for us, but we can go expand into that if we need to. And there are times where we go do that. So that's kind of our buffer zone. All right, let's switch and talk a little bit about operations. So the people up at the top here behind the low sign, that's the crew chief and his lieutenants. They really are trying to keep a big overview of the race and make sure everything is going according to plan. So you think of the things that we do in operations, really trying to keep an overview of the service and making sure everything is going according to plan. Now this chart here may look like an SPS chart, and in some level it is, but the reality, this is actually autoscaling. I mentioned earlier that we scale up and down the number of instances that we use. If you look closely at the two lines here, one is the desired amount of capacity you want, and what is the current amount of capacity. You would like those two lines to stay very close together, because that means that you're not behind, you're not wasting capacity, you're not overusing it. So we have a set of systems internally that we use to try to predict what capacity we're going to need before we need it, so we can start scaling up. A lot of people may ask, so why do we auto-scale? Why don't you just, as some people like to say, just pin at the top, figure out what your maximum capacity is, just go get that, and just hold on to it. You know it's there, you don't have to go worry about it. There's a couple of reasons why we do this. One is sort of philosophical. It's the cloud. You have capacity you can use, you have capacity you can give back. You might as well go do that. The other thing that on the philosophical side is, well, Amazon provides us this service. They make it very easy for us to do this through their APIs, et cetera. So we can build systems internally that make this easy for our engineers to engage with. But ultimately, it's a pragmatic reason, which is money. The fact that we can take our reserved instances and reuse them again essentially means that rather than pinning every service high at the maximum, we can now actually use much less total capacity, reuse it again and again, right, and save ourselves money. So, list of services here. Encoding, I've already talked about. Pre-compute, trying to figure out what you all are going to watch next. Failover, so that operation I talked about, being able to fail over in 7 minutes, we wind up using trough capacity for that, because you know there's capacity available in the region you're going to, and you just need to start scaling it up very quickly. Red-black pushes, so one of the things that we do in terms of rolling out new services, is we'll spin up a cluster exactly the same size as the service we're about to spin down. We'll run them in parallel for a bit, make sure that we have no problems, right, and then we'll spin down the old one. And the service is resilient enough that if there are problems, you discover it very quickly. You can quickly flip back to the previous cluster. And there's many more things that we can do that we take advantage of the fact that we can scale our capacities up and down. Now, if you're thinking about doing auto-scaling, there's two things you need to keep in mind here. There's reactive auto-scaling, which is basically, my load is going up, I need more capacity, and I need it pretty quickly here. And then there's predictive auto-scaling, which is essentially our events in the real world. And I know I'm going to need capacity at some point in the future, so let me start scaling now in anticipation of that. So now another question for the audience. So who has kids, and on Saturday mornings, they get up and watch shows on Netflix? Okay, we know who you are. So it turns out we see a spike Saturday mornings, right, from all those parents who are putting their kids in front of their televisions or computers. And what that led to is that there's the idea of predictive auto-scaling, which is, all right, you know this event is going to happen once a week, so you want to start scaling up early Saturday morning in anticipation of that. We actually have a sort of software that essentially looks at events over a longer period of time and kind of goes, so over the last week, here's what we've seen. We predict that next week will be very similar, so now we're going to start adding capacity in anticipation of that. And so the thing about auto-scaling is that we wind up doing both of these. A lot of people think about auto-scaling as just the reactive side of it, but the predictive side of it is as important. Yes, I hear.
I have to ask, what's the gray line? What's the stripe on the gray line we look for?
So I don't know the exact answer to that question. My guess is it's one of the Kong exercises. Because what you would see is you would see a spike up of SPS into the region you failed into, and if I showed you the other regions, you would see a spike down. Right? But usually when we see that, it's either a Kong exercise or some other failure has happened which has caused us to redirect traffic to one of the other regions.
Scale down for the Super Bowl?
No comment. Okay, so continuing on here, so let's look at some of the building blocks that we have in place in order to make all of this possible. At the bottom of all of this is the other half of my job, which is operating systems. So we use Ubuntu, it's Linux, it's open source, free, etc. We basically use what we call immutable infrastructure. So as a developer, you'll develop your application. The majority of what we do is in Java, although we use a ton of different languages. We use Ruby, we use Python, C++, Scala, you name it. There's someone writing in it inside. Actually, not Fortran, but there's probably someone writing with it inside Netflix. All of that gets baked into what we call a base AMI. And so that's the unit that gets deployed into Amazon. So in this case, you'll see it's got Java, it's got a web container, Tomcat, it's got Atlas monitoring as our monitoring framework. So basically everything that you need is baked into this AMI. We then deploy that AMI directly into the cloud. Now, the reason it's immutable is we never patch it. If you have a problem and you need to fix that, then what you'll do is you'll bake another version of the AMI and you'll deploy that. So that avoids the problem of configuration management in the cloud. So you know that the thing that you're running is the latest thing. And if you're going to change, just go upgrade to the new thing. We're in a process now of moving between major releases of the operating system. That's my project for this year. The thing on your left there is a tar. So it's trusty tar is the oldest release of Ubuntu, and then Xerxes, which is the new release of Ubuntu. So the fleet right now is about half and half. Actually, about 57% is running the new release. But we're in the process of doing this major OS upgrade, over time, over all these VMs. And essentially what we wind up doing is we go to the services, we say, there's a new release of the operating system. We want you to go bake on this new release of the operating system and deploy. Let us know if you have any problems. If you have problems, then roll back because your old version running trusty is still around. You can roll that forward again. If you really are worried, you can do a red-black. And so do one side with Xenial, the other side with trusty, roll those forward, etc. But a lot of the way we manage our infrastructure allows us to go do things like this. In fact, the way that we think about this is it's a lot of push buttons all in a row. So first thing you do is you build your application or you build your service, you get it working locally. We have a test environment where you can test it in, although it's not as good as our production environment, which is where we do the bulk of our testing. You bake that into an AMI, you deploy it into a thing that we call Canary. So you will deploy perhaps one instance of that as a virtual machine. We can use our load balancers in order to send traffic to that Canary, and you can see what happens with it. So we will send it production traffic, and you'll see how it behaves. If it doesn't behave the way you expect, you kill the Canary. Because people do retries, they actually probably will not notice anything's gone wrong other than maybe a little bit higher latency. And then you'll just fix it and deploy a new Canary. Once you're happy and you're ready to actually roll into production, you'll roll it out into one region. So now you have two regions running the old stuff, one region running the new stuff. You'll now start to see scale on your service. If it works under scale, which is why you basically have this timer here, so you wait a day maybe to make sure it works under scale, then you'll push the other regions. Now, the beauty of all of this is the easy button here, is all of this is basically one click for the developers to do. We have a tool which is open source. You're all welcome to use it if it fits into your environments. It's called Spinnaker, and it's an industry thing that a lot of people are working on. Google has a big group working on it. A bunch of other companies have big groups that are working on it. But essentially, it allows you to describe a pipeline for deployment of an application. And you essentially do a drag and drop thing that says, okay, here are all the steps you need to follow. In this particular case, there's a manual go, no go, right? So in the case of a canary or something, you may say, all right, at this step, a human now needs to get involved in order to make a decision. Over here, he says, wait 4 hours. So now you can insert delays into your pipeline. So what we have is hundreds of pipelines for all the different services that we deploy. And each of the different organizations that maintains a service will have the pipeline that they'll control. Okay, so for a lot of you, particularly anyone who's actually been in DevOps or worked in data centers, this may feel like DevOps while running with scissors. Basically, we change stuff in production live. We're kind of constantly working on churning things. We test on our customers, basically, because customers are convenient to test on. Now, the reality is, it really isn't like that. We have a ton of sort of safeties built in order to improve our reliability. So each of the little boxes here, as I said, is multiple virtual machines. If one of them fails, there's other machines to take up the slack. People rarely run at 100% CPU utilization, so you always have headroom to grow into. So if one VM fails, there's headroom on the other VMs. We do a thing that we call, not the chaos Kong exercise, but we do other chaos exercises. And what we'll do is we'll go and randomly shoot virtual machines in different services without telling the people who own them, which means that your service needs to be able to respond to that type of failure. So when you start out with an architecture like that and a plan like that, then your engineering organization kind of rises to the challenge and starts to build things which are resilient to failure. The other thing that we've done is that we have what we call circuit breakers between the different microservices. So if service A is talking to service B and the latencies suddenly shoot through the roof, a circuit breaker will trip. And then that tells service A, okay, you need to do something else other than depend on service B. And everyone kind of up and down the chain has these types of things. So you're always expecting whatever the next failure is going to be. And that allows us to now then deploy things at a very rapid pace. And for us, one of the big goals is speed of innovation. How fast can we innovate and get new things out there? Oops. All right, tactics. So NASCAR pit crew, in 10 seconds, they can change 4 tires and put in 22 gallons of gas into this car and get it back out on the track. So every second that car is still in the pits is several hundred feet on the track and could be the difference between winning and losing a race. So I think of my team as the performance pit crew. Is people come to us, they expect us to help them out. In fact, what the pit crew here can do is they can make these minor adjustments, right? A half a pound of air pressure in some tires, a little turn on a spring, right? And that can really change the way a car performs. So my team is very similar in how they approach the world. People come to us and say, we need you to help us go make this thing go faster. What can you do for us? This is Slack, an application we use for instant messaging. And this is pretty much how we see the world. See at the top it says, when I see these pink vertical lines, what does that mean? So that's an engineer coming to us and saying, so I'm seeing this behavior in my service. I'm not really sure what it's trying to tell me, but someone should be able to help me figure that out. So what we do is we bring to bear a bunch of tools on that. What I'm showing here is an example of something called a flame graph. And so I'll take a quick poll. So who's heard of flame graphs? Yay. Okay. The rest of you should all examine flame graphs. They're really fun things. So essentially, what this is showing me is for a particular application, the x-axis is essentially usage on the CPU. The y-axis is stack depth. So you can see all the routines that are running on the CPU at that particular time. In this particular case, the people who own this application said, we rolled out a new version. It's not behaving the way we expect. Can you help us figure it out? One of my engineers ran this flame graph, got this result. Well, maybe a big surprise, but essentially half of the CPU is going to one routine. luckily, the way this application was constructed, we could turn that routine off. It wasn't really critical to what the service was trying to provide. So we turned that off in a canary and gave it a try. CPU utilization dropped dramatically. That's the low line there. Request latency also dropped dramatically. So actually, we had found the problem. It turns out that fixing this one problem saved us 13 million CPU minutes, which was almost 25 years, which is a ton of money. So as my boss likes to say, this is the reason they keep us around. You swoop in, you save the company a few $1 million, then go back to your desk. But going back to my analogy of the sort of performance pit crew, this is really what my team is about, and what we're trying to do for the company is to help people solve problems like this as quickly as possible. Another graph. Unfortunately, I can't show you the numbers on it. But one thing that we're starting to look at now is to really understand how our customers are perceiving their experience with the service. So I'm now branching out from looking inside the data center and looking inside the cloud to looking at customer experience. And we're taking a ton of measurements on what customers do and how they interact. I was going through a set of our data at some point, and I came across this graph. It's a particular mobile device, I won't say which one, and this is measuring the time to first interaction. So from the time you launch launch Netflix to the time you can actually start to interact with it. And suddenly it had climbed one day. In fact, I remembered the day when this happened. This delta is almost a second. What had happened is that the development team had pushed a new feature that had this side effect. The side effect was actually slow this down by 1 second, but they hadn't actually noticed in their testing. And actually, it's not clear that their customers had noticed quite yet. But because we were actually collecting data from millions of devices, we were able to aggregate all that data and see this very quickly and visualize it for them. They were able to push a fix. And actually, you can see the trend line going down there. It's actually the fix sort of working its way out through the population of devices. So one of the things that I'm trying to look at is, so how can we start to use this type of visualization in order to find problems out in the field and fix them very quickly, or potentially to predict problems when they're about to happen. So sometimes we can actually, in fact, I have a set of charts that's not here, where we can actually see things getting worse over time. Because you push a fix, and as the population for it grows and grows, you start to see a larger and larger effect. And so we're talking about, can we put alerts on things like that? So those are just a couple of examples of things that we found with my group and the performance engineers. We have a set of tools that we built. We basically are always building tools and go look at things. I wanted to just highlight one here called Vector. It's also open source. It allows us to do very fine-grained, almost microsecond analysis of a particular instance. So if someone comes to us with a problem, we can go dive into it, log into the instance. We can get flame graphs. There's actually many more flame graphs than the one that I showed you there. We can do per CPU utilizations. We can do number of context switches. But essentially, we select an instance type. We figure out what metrics we want to go look at. We can get flame graphs, near real time per second sort of metrics there. And this is actually just one of the many tools that we have available in our arsenal of tools that we apply to these problems. Our goal in performance engineering is really about improved observability. So all the way from the macro, so how is the cluster doing, down to the micro, so what's happening on the instance. And in fact, what we're starting to do is to work with Amazon and Intel on really fine-grained performance analysis and understanding what's happening at almost the sort of cycle level on their processors. Okay. So everything that I've been talking about up until now may feel to some of you like trying to change the wheels on a car while it's moving. And to a large extent, I could say that's kind of how my day feels from time to time. The service obviously is available 24/7. We're pushing things into production, as I said. We can't stop for anything. We're trying to innovate at this really fast pace. And everyone is sort of working independently in order to try to solve this one big problem, similar to what the guys on this Jeep are trying to do here. Also, there's a problem, so if you make a big mistake, it could end in disaster. We're going to try to avoid that. So I think that the thing that really helps us navigate this is really our culture. And that's the thing that I always come back to when I think about, so why is it that I go to work, and what is it that makes the company as successful as it is? And the culture comes down to three basic things. Freedom. So freedom, ability to go do the right thing at the right time. What we wind up doing is we hire senior engineers, so pretty much everyone I work with has been in the industry 10 or more years. So they know the drill. And you give them the freedom that they need in order to go solve important problems. So I can sit down with my OS engineers and say, all right, there's a new release of the operating system coming out. We need to go roll that out. Go figure that out. Let me know when it's done. And they will go off and they'll go handle that for me. Now, responsibility. Now, with freedom comes responsibility. Most of you would probably be surprised to find out that everyone in engineering at Netflix has the root password to every VM that we run. So I could log on and I could do enormous amounts of damage. But we don't do that, because if I did that, I would have to take the responsibility for my actions. The other thing that's interesting about the company is everyone in engineering is an insider. So if you want to know to the minute how many subscribers we had, I could go look that up. I could tell you what we paid for the last bit of original content that we made. But nothing really leaks out from the company. And again, that's part of the whole freedom and responsibility thing. So this is a mantra that we really practice and we try to instill in people when we hire them and as we kind of grow the company. Lastly, context. What we try to do is to make sure that everyone has the context they need in order to use their freedom and responsibility to make the right decisions. So I mentioned that I was an insider and that I can find out information. So sometimes that's very useful. For instance, knowing what the studio is up to helps me plan how I want to allocate my performance engineers. Knowing how well Stranger Things does will help me think about, okay, here are performance problems I should go take care of. So a lot of what I spend my time doing, a lot of what my boss spends his time doing is trying to give my engineers and other people the context they need in order to go solve the important problems that need to go get solved. So it's a lot of meetings, a lot of talking to people about things, but in comparison to other organizations I've been in where your boss kind of comes to you and says, I need you to do A, B, and C. It's like, okay, I'll get on that right away, right? This is very much about, so here's the problem we're trying to solve. And I depend on you and your knowledge to go solve that problem. Going back to the race analogy, the way I like to think about this is that we're in this race. It's a race for customers. It's a race for innovation. The people who are really good will win that race. And at Netflix, we're trying to be the people that win that race. So I've talked about the strategies that we apply to try to figure these things out, the operations that we do, the tactics, and the culture. All of these things I think are really important to being the first people across the finish line when it comes to you deciding if you're going to watch us or watch one of our competitors. For me, as the performance and operating systems manager, that's the thing that I focus on, is making sure that I'm doing what I can and my people are doing what they can in order to help people innovate as quickly as possible. But wait, there's more. So if we do that, then everybody is happy. Our customers, us, our stockholders. So I'm Ed Hunter, by the way, and I guess I can take questions now. All right, you're going to ask me about my 1984 paper, I can tell. Wait. Before you do that, I will answer the question that someone is going to ask me. So no, I do not get Netflix for free. All right. And Longmire, season 3, I think is coming soon. Yes, okay.
You had talked a little bit about the autoscaling, how you're looking both
Reactive and predictive.
predictive. I didn't see too much discuss, unless I missed it, meeting with the business to discuss growth, KPI type discussions. Do you have those discussions with the business? For example, there's a big promotion coming, you're going to give everybody Netflix for 5 months, I don't know, or something.
Yes. So, yes. So not really. The infrastructure is resilient enough that outside of those kind of sort of macro events like the holidays, we just depend on the services to scale up and scale down appropriately. Now the capacity people track this on a weekly basis, and I, for instance, go to a weekly meeting where we look at who the top 4 or 5 people are in terms of growth, and if they seem to be kind of exceeding a trend line, then we'll go and talk to them and say, so do you know why you're growing so quickly? Is there something we can do in order to go turn that? We have an aggregate target that we have in terms of what we think our spend should be growing at relative to what our user base is growing at. And as long as we maintain that, then everything kind of works itself out.
Can I ask one follow-up?
Yeah.
You also mentioned reserved and on-demand instances.
Yes.
We're looking at that now. Have you found that there's a sweet spot that determines how many should be reserved based on your graphs that you showed, and how many should be on demand in terms of cost? I mean, for example, if you look at the baseline usage and say that's how much I'm going to have in terms of reserve capacity.
Okay, so your question is basically, where's the boundary between the number of reserved instances and when you go into the on-demand pool, and do we have a way of sort of figuring that? The better person to answer this would be the capacity engineering team. The sense I have is that we try to get enough reserved instances to really cover our needs, and that we only go into on-demand as an exception. Right? So we aren't planning to be in on-demand. Okay, yes, sir.
Can you give us an example of your service level goals?
Service level goals. Yes.
Different demand during different time of the day, holidays, so are they tied together or not?
So our service level goals are ultimately tied to the streaming performance. So what we look at is, in fact, actually, I do have a good answer to this. So if you look at the SPS curve, you can then go from that to say, so any particular time of the day, here's how many streams we think will launch. If that number of streams does not launch, right, then that becomes your sort of service level goal. So we will count the number, what we'll call number of streams missed from an event, right? So for instance, PlayStations or Xboxes or something start to have problems. We then start saying, well, someone could have streamed but did not, so we'll count that as an event, and then we'll track the number of those.
So this is throughput. What about response time?
Response time varies so dramatically around the world that we do look at response time, but it's really on a kind of per device and per region basis. And part of the work I'm doing with looking at customers and their perceptions is trying to understand how response time figures into that. Although I think I may not have answered the other question you're asking. So there's 2 parts of response time. There's what our customers see, and a lot of that is determined by the latency of the network that they're on and various other factors. Then there's latencies inside the cloud and what our response times are inside there. That generally is a negotiation between the different services. So service A may say, okay, I need to get responses in 150 milliseconds, and they'll look at their downstream services and work to try to make that happen. And we'll come in to help them go figure that out. So if you still need more, we should chat later too. Okay. Yeah. Yes.
Okay, so first, I want to shout out, like I said in person, thank you for your team for the flame graphs and the engineering blog posts that come out. They have helped us build a lot of things we really honestly could not have built otherwise. So awesome. And then the question I have is about this user experience measurement that you're talking about. So I'm curious, this is something we want to get better at as well at MathWorks, and one of the things we use for this is in product telemetry, sort of.
Mm-hmm.
And I'm curious, like, is there Amazon tools that can help you for the server side stuff? Like, how do you do it? Can you say a little more?
Yes, I can. So the question is about what tools we use to measure client performance, basically. So we use a set of histogram tools that we got from Facebook that came out of some work that they did with Chrome. And since we control all of our devices, since we install the application there, we can actually take a set of measurements at different steps along the way, and we already have been taking those measurements. We wind up collecting those in the device and essentially bucketing them into a small sort of histogram. We then send that back once an hour or so. And collect that in a big data stream, which we then analyze once a night in order to produce graphs like one of the ones that I showed you. In addition to that, every device sends back information which goes into one of our big databases, which we can then do a set of analysis on. So it's really about the devices telling you what's happening with them, and then collecting that and then analyzing it. Yeah. All right, so back there behind in the lights. I remember you. You came in late.
So I'll try to do it before. At our company, we have some predictive insights analytical packages that basically do a 15-day moving average baseline, high and low, to see a KPI that starts to trend upward before it becomes a problem. You had your flame graph up there, which showed processes consuming 50% of the CPU on that server. Do you have things now that kind of predict that ahead of time more than after the fact?
Not currently.
Things like Storm or any of the open framework?
Not currently, although there's some stuff we're talking about internally that might do that. So for instance, actually I heard a rumor, is there someone from Facebook here? So don't hide out. But for instance, I believe Facebook does flame graphs like on every build or something along those lines, right? And does these comparisons to see if things have changed. So there are ways to start to look at this, and we've been talking about that. Was I right? I see. We'll chat afterwards. Yes, sir.
You've talked about testing in prod. You've talked about sending data back on a daily basis. Do you do any real-time monitoring?
Yes, we do. We do a fair amount of it. So the people in site reliability can get a bunch of real-time data. We actually have a separate data pipeline that will give you real-time data on how things are doing, both in the service and out in the field. So we have multiple data pipelines that deal with that. Yeah. Yes, sir.
So you talked about your AMI and the VM stack there. Are you guys strictly VM based for your microservices, or are you guys doing a lot of stuff that is, based on containers as well? What's your strategy there?
So yes, we are doing containers. We've started moving to containers recently. We have our own internal container management system, and we'll be doing a mix of containers and virtual machines for the foreseeable future. Yes, ma'am.
You were talking about monitoring and then SPS charts. So because of the huge, because of the too huge size of your data center, do you?
Actually, Amazon's data center, but go on.
So is the capacity engineering team doing the prediction analysis manually, or you have something like Alexa telling, hey, this is the trend, so how
It's more manual now, not machine learning yet. It's more manual analysis right now. And although we're about to start a project that I hopefully will be working on to try to make it less manual. All right. I should check my time here. Oh, it's 5:15, which means you all would like to be on a break now. All right, any last questions? All right, so a couple of things. Before you do that, two quick things. So I brought presents. I have stickers, right, for various open source things and some Netflix stuff if anyone's interested in those. And I actually brought 5 copies of a book that the Chaos team wrote about chaos engineering. So if anyone's interested in that, let me know. And hopefully something that I've said you all can take back with you to the places you worked and apply it. And if not, hopefully it's been at least interesting. So thank you all for your time.